All right, guys, can you hear me? Haven't done this in a little while. All right. So, what I'm doing, you guys can just see my iPad screen, but I'm recording it through the computer. And what I want to do is I want to put Zoom chat on the recording screen. So I need to get your permission first, because if you guys comment in Zoom chat, your name, of course, will be displayed. Is anybody uncomfortable with their name being displayed? Gotta ask. I don't want to get in trouble again. It's okay. Not uncomfortable. It's okay. Okay. So I'm going to move Zoom chat into the recorded screen so that I can keep an eye on it. All right. So you guys can hear me. You guys can see my screen. I'm going to write on my screen. Just let me know if you guys can see the writing. Oh, all right. Awesome. All right. You guys want the camera on? You'd be staring at my forehead the whole time. Or I guess when I'm looking down. All right. Wow, you guys are going crazy. How many people? 200. All right. Can you see me? I can't tell if it went on. Hold on. Let's see. Video settings. What do we got? Wow. Not very flattering. All right, let's see. Can you see? I have no idea. All right. I'm taking that you guys can see. I can't see myself. I wonder if there's a way I can see myself. I guess not. It doesn't matter. Hopefully it's not too cringe. I'm going to be looking down the whole time, so that's why I'm not really sure if you guys wanted the camera. You guys are extremely flattering. I really appreciate it. All right, so before we begin, first things first, always, how are you guys? Number one thing, how are you guys? Crying? Better now? Great.
I'm good,
Good. Math midterm tomorrow? Wow, brutal. Number one priority, your guys' number one priority. Not math, not statics, not chemistry. Well, chemistry sucks anyway. It's always yourself. Take care of yourself all the time, okay? Number one, all the time. If you don't take care of yourself, you're going to lose your mind. Trust me, been there. First year, sitting in Lister in that tiny little room, it's not very fun. Actually, I should probably make a quick disclaimer really quick before I get in trouble again. This is on my own time. I'm not getting paid by the university. I'm not doing anything like that. So this is purely my content. So of course, as you guys know, I sometimes say things that do not reflect with the university policies. So if that makes you uncomfortable, may want to leave. I'm going to try my best not to offend anybody, of course. But I just want to throw that out there. Okay. So now that I've done that, I can talk shit about Lister now. Being in Lister in that hot room with Eng 130 midterms, math midterms, it's not fun. And it doesn't matter where you guys are. What happens is you spend so much time studying that you don't really have a chance to go for a walk, go to the gym, do all those fun things. So make sure you take that time and just relax. Don't just sit in a room all day. It's the worst thing you can do. Right? So take care of yourself. Number one thing. Review today. The review today. I'm going to cover three questions. They come from 2012 and 2013 midterms. I picked the hardest midterm questions that I could find. And they all deal with moments. From what I heard, that's what's going to be on your midterm. Moments. So I picked moment questions. I know in the video I said that there's one midterm. That when I used to teach it, that's what it was. Of course, they changed it, so I look pretty stupid, but what can you do? I'm just glad that you guys are enjoying the content. You guys are going crazy on chat. Thank you. You guys are all too nice, making me blush a little bit. For those of you guys who don't know, I'm Clayton. I'm an instructor at the University of Alberta. I mainly teach this class, but I also teach a lot of solid mechanics. It's basically simulation math. You guys have seen simulations where you simulate an object and it gets all colorful, the stresses, all that garbage. That's kind of my specialty. That's what I'm doing this semester, so unfortunately I can't be with you guys. The good news is you guys have awesome instructors. You guys have Dr. Lobo, Carlos. He's great. He was the one that got me into teaching, believe it or not. Very, very close relationship with Dr. Lobo, Dr. Carlos. He's the absolute best. You guys have Dr. Yuxing Chen, very good friend of mine. I'm not sure if they made it in here. Little secret. Again, secret. I'm not allowed to say secret in the censored videos, but these aren't censored videos, so I could say secret. They don't have a Discord. Dr. Chen's section doesn't have a Discord, so I wonder if they made it in today. I'm not too sure. Hopefully they are here too. Every other section has a Discord. Dr. Layla, she's been teaching statics since I took statics myself. She's a legend. And then you have Maha, who came in. She's been absolutely fantastic. And then you have Dr. I want to say Manuli. Honestly, I've never met her. She took my section. So if you guys are in that Dr. Manuli section, that's actually my section. You guys would have had me if I was teaching. But I'm not teaching, so you guys have her instead. But I'm sure that she's just as great as all the other instructors. All right, so we're going to jump into it. I'm not sure what they gave you for midterm material to study for. I have access to all the midterms, all the way back until 2009. I was going to say 2012, but all the way back to 2009. So I have them all. I picked the hardest questions, but I need to give the disclaimer. I have not seen the midterm this year that they have prepared for you guys. I don't have anything. So I just picked the hardest moment/force reduction questions I could. Will it be tested on the exam? Maybe. I have absolutely no idea. I'm hoping that this will at least help. We're going to go through these questions, talk about the tips, the tricks, all that fun stuff. But if the midterm tomorrow is something completely different, I'm so sorry. Again, a little disclaimer. I have no real affiliation to the course this semester. I just gave my videos. So hopefully this helps. But if the midterm is something completely different, I apologize in advance. All right. So we're going to get started. I know I can talk on for a long time. It's already been 10 minutes. In my lecture today, I spent 20 minutes just talking about nothing. And the kids, I think, were getting a little bit upset or cranky, stuff like that. So we're going to begin. Let's start the fun. All right, question 1 from 2013. Now, 2013 here, so again, we'll put 2013. This holds a special place in my heart. This was my midterm. This was my midterm when I was in first year, and I hate it. I hated it. It was garbage. I got 40%, something like that. The average was 60, of course. I looked pretty dumb because it was a mean midterm. This was one of the meanest midterms. Again, I picked the 3 hardest moment questions I can find. 2 are from 2013. Absolutely just a terrible year. Terrible year. So we're going to go through it. This was the nicer of the 2. We're going to finish off with the hard one. So 2013. It has 3 questions, and these are what the midterms used to be like. So question 1 says, as shown in figure 1a, 5 forces act on a prism. All right, so we got 5 forces we're dealing with. It says part A, those 5 forces can be reduced to an equivalent force couple system as shown in figure 1b. Determine FR and MR and express them in Cartesian vector form. So again, very standard type question that we have here. Basically, we have 5 forces on the left, and we want to convert them into a single force and a single moment, as we see on the right. Again, that's the whole name of the game in this case. Now, to do this, all we need to do is add our moments, add our forces. That's the trick here. There isn't really anything special besides we just add everything together. The only thing that we have to consider is that when we add a force together and when we start adding moments, every force creates a moment. So we're going to go through here. What we need to do is we need to look at kind of the tips and tricks. Typically, again, I don't know the final this year. I don't know anything like that. When you guys have a lot of forces, they can be reduced. There's couples, there's stuff like that. And if we look here, we have couples. Again, the definition of a couple is two forces that have the exact same magnitude. They're parallel and in opposite directions. So if we look here, as we can see, we have 25 kilonewtons going upwards, and we have 25 kilonewtons going downwards. So they meet the first one. They have the same magnitude, 25 kilonewtons. One is going up, one is going down, so it's opposite direction. And then finally, they are parallel to each other. So these two create a moment couple. But this is the first trick that starts to get students in Eng 130. When we talked about these simple moment couples, in this case the 25 kilonewtons, we've always done it in 2 dimensions. So if I want this moment couple in 3 dimensions, well, how do we do that, right? Like that's the trouble that we have here. So here's the secret to moments that act in a plane. If we look at this question, these two forces are very special because as we can see, they act in the ZY plane. I'm hoping that you guys see this. I got a question, is this being recorded? Of course. I wouldn't just give a midterm review to only select students. Of course it's going to be recorded. It's going to be in the link on eClass. I put the link there as a placeholder. I know I pissed a lot of you guys off, but I had to do it. Come on. 1,200 kids looking at that link? I had to. But back to the question. These two forces act on the YZ plane. All right? They're acting on the YZ plane. Question for you guys. Let's see. Let's see how much you guys know. In 2 dimensions, in our XY plane, forget this question. Think about what we have in 2D. XY plane. If I have a force that creates a moment, what is that moment about if it's in the XY plane? Oh, you guys are too smart. See? Z. So if I look at this question, and I see that I have 25 kilonewtons in the YZ plane, what's that going to create a moment about? X. See, you guys are too smart. You guys don't even need this review. You guys all have it. So what we can do is we can say, okay, from our 5 forces, let's start off with the 25 kilonewton forces. I will post the PDF solutions. I have them all here. I'll post them after, so you guys don't have to worry too much. 25 kilonewton forces, and we know that these are going to be a couple. Now, if we look at the definition of a couple, the moment couple, so I'm just going to say M1, is equal to one of the forces times the distance between them. So M1 is equal to the force times that perpendicular distance between them, something like this. If we look here, this is simple. The force itself we know is 25 kilonewtons, so that's not too bad at all. I'm going to say, okay, well, 25 kilonewtons. And the distance between them, if we were to look at our figure, we can see that the distance between them is 4 meters. So what's going to happen is we have 4 meters, so we know that this is going to be 100 kilonewton times meters. Kilonewton per meters. So far, it's not too bad. Here's the trick, though. We know in 2D that's what it would be. But we have to associate a direction. Is this going to be a positive or a negative value? So what we need to do, I know I personally take my pencil. I'm not sure whatever you guys are taught. Again, whatever your instructor teaches you is however you want to do it. But this is how I do it, is I just take my pencil. I say, okay, on this side, I got 25 going up. 25 going up. This side, I got 25 going down. As we can see, it starts to create a clockwise rotation. Do you guys see that? I'm not sure if the camera's inversed. I'm really not, so I'm hoping it's not. But we get that clockwise rotation. Now, clockwise is negative. So we know that this is going to be negative. Because again, if I were to just kind of simulate it with my pencil, it starts going clockwise direction. So this is the moment in a kind of a 2D case. So we can actually express this in Cartesian vector notation. We said that if our forces are in the YZ plane, the moment is in the plane perpendicular, or the axis perpendicular. So in this case, X. So we know that this is going to be negative 100I plus 0J plus 0K. Just like that. And it has units of kilonewtons per meter. Can I explain one more time why it's negative? Of course I can. Again, you just want to try and simulate it. So let's just zoom in. I'm looking at those two vertical forces. Take my pencil as that line BD. Okay, so on this side we have B. On this side we have D. So what I'm going to do on B, as we can see, it's going upwards. And on D, it's going downwards. So if I were to just pull this side up while pulling this down, my pencil starts to rotate. That's it. I'm just pulling one side up, the other side down. And we can see that in general, it's going in a clockwise manner. Clockwise is always negative. Another question, if J and K are 0, do you need to write them down? I like to write them down. It's one of those things that it depends on who you get. Whoever is marking the exam, sometimes they're mean, they dock marks, sometimes they don't. Stuff like that. So how did I get the CVN? It's one of those special tricks that if my forces act in a plane, the moment will always be along the axis perpendicular to that plane. If I have something in 2D, X and Y plane, my moments will always be about Z. In this case, these forces act in the YZ plane, so that we know our moment's going to be around the x-axis. So hopefully that's not too bad. All right, perfect. I'm hoping I'm answering some of your questions. I'm going to try and answer, but at the same time, still go on. So that's going to be our first force. We know it's going to create a couple. We have what M1 is. So I'm just going to put M1. So we're going to go to the second set of forces. So I'm going to just go up here. I'm going to erase everything. And now let's take a look at these forces. We have 120 kilonewtons going to the right, and we have 120 kilonewtons going to the left. Do these create a moment? Of course they do. They're forces. Forces create moments, but this is a very special case. These forces have the same magnitude, all right? So there's kind of check number one when it comes to couples, same magnitude. They got opposite direction. Oh, looking very sexy now. Starting to get into that couple territory. But there's one problem. They are separated by non-zero distance. Non-zero distance. Or separated by zero distance. Zero distance. So what's going to happen with these two forces? If I consider them both together, are they going to create a moment? What do you guys think? No. No. No, you guys are too smart. No. Best way to look at this, if I were to just come down here and I were to just take, let's say, a beam, and I were to put one force, P, going one way, and I have force P going the other way, each one separately will create a moment, but when I consider them together, they cancel each other out in terms of moment. Does that make sense to you guys? They start to cancel each other out. So that's what's going to happen here. If you want, you guys can still use the moment formula for couples. I can say M2 is equal to force times that perpendicular distance. We know the force is 125. But if we look at the distance between these two forces here, there is no distance. It's just straight up 0. So what this would be 0. So our moment couple in this case, 0. Hopefully that's not too bad. Isn't the distance for... I'm looking at these two vertical forces. The distance between them, this distance, if I were to highlight this, this is 4, but I'm looking at the perpendicular distance between them. The perpendicular distance is 0. Does that make sense? If I were to extend one of these forces all the way to the other side, oops. Let's say that this 120 over here, if I were to just extend this line, it intersects with the other 120. It has to be that perpendicular distance. Oh yeah, it's 120, not 125. You guys have seen this a lot in the example videos. I have one thing in my head and I write it down, and then everybody laughs. So hopefully that makes sense. The distance between these two are not the same. Question for you guys though. If one of these, let's say this one, instead of 120, this was 130. Is the moment between them going to be 0? Are these two forces going to create? Exactly. It's absolutely not. The only reason why it does is because they're both 120. Both 120. So those are those two forces. Again, these are all kind of those tricks where you take a two-dimensional case, convert it into a three-dimensional case. Let's get into the fun. So we have our first two. The third one is going to be this force right here. FC, which is 300. So I'm just going to come down here. I'm going to say, okay, but the third one I'm going to look at is that FC. Is there any trick to FC that we can kind of try and convert it into two dimensions? What do you guys think? No, not really. That's kind of what sucks about it. If there's no trick and we have a moment in 3D, what do we need to do? What do we need to do for 3D moments? Fish, cross product, exactly. So whenever you guys see something like this in 3 dimensions, and it's not in a specific plane, remember, these forces over here, they were special because they were in the YZ plane. FC, on the other hand, it's not in any plane. That's what makes it so tricky. So in this case, we have to do cross product. Now, when we do cross product, we need a couple things. We need our force in CVN. Question, what does M1 and M2 represent? They're just how I'm labeling the moments. Moment 1, moment 2. You can name it whatever you want. Have I ever seen a wrench on the midterm? Of course. Of course I've seen a wrench on the midterm. One time. But I think it was confirmed that you guys are not going to have a wrench, so it shouldn't be too bad. Yeah, you're told no wrenches. Yeah, no, exactly. That's a big sigh of relief. Wrenches are the worst. Again, I said, you make your professor angry, they're going to give you a wrench. And then they got in trouble. I'm not supposed to say the secrets. All right. So we're looking at this last force, FC. And we said we have to do cross product. Again, we have to do cross product. I'm going to come down here and say, okay, FC, this is definitely going to be cross product. Now, in order to do cross product, we need a couple of things. The first one is we need our force, FC, in CVN. We need our force in CVN. So we know that our force FC starts off at point C and it goes over to point B as such. How do I get this force in CVN? What do you guys think? Remember, I said that there's basically 3 different ways to get a force in CVN. I said there's trig, I said there's coordinate direction angles, and then I said there's position vectors. Which one's this going to be? Position vectors. See, you guys got this. It's going to be position vectors. Because what happens is if I were to draw a position vector along this line, so I'll do that in, let's say, orange here. If I were to draw a position vector along this line, it has the exact same direction. So I'm going to call this right here position vector. The question for you guys, is this going to be CB or BC? CB or BC? CB, exactly. The first subscript is where you start. We're starting at C. And the second subscript is where you end, which is going to be B, just like that. So what we're going to do is we're going to come down here and say, okay, the first thing we need to do is get our force into CVN. We do that by using the position vector RCB. Now, is this going to be RB minus RC or RC minus RB? All right, B, exactly. B goes first. That's kind of the first trick that a lot of students mess up on. It's going to be RB minus RC. You take where you end up and you subtract where you started. That's the key. Where you end up minus where you started. So all we need to do is take our coordinate points. If we go up to the top here, we can see that coordinate C over here is going to be 4 units in the X direction. It is 4 units in the Y direction, and then it is 0 units in the Z direction. Hopefully that's not too bad. At B up here, we can see that it is just above the origin, so we know that X and Y are 0 and 0. And finally, it is 2 meters above the origin, so it's going to be 2. So what I'm going to do is I'm just going to scroll on over down here. We know that we have 2, 0, 0, subtracted from 4, 4, 0. It's hard for me to write. I probably look pretty silly. I write sideways. It's one of those little fun facts. I write sideways. So if we do this, we get our position vector as 2 minus 4. Actually, no, that's messed up. See? I make mistakes all the time. This should be a 2 at the end here. Probably making you guys cringe pretty hard, hey? Clayton lore? What do you guys want to know about Clayton lore? That's an interesting comment. Clayton lore. I'm from Red Deer. Did you guys know that? I'm from Red Deer. Favorite game? Favorite game? That's hard. I have so many games. Right now, Animal Crossing. I'm so excited for the new update. PC specs, I think I sent them in one of the Discord. Red Deer's the bathroom break of Alberta. That's probably the most true thing I've ever heard. Some other people from Red Deer, wonderful. Warzone, don't really play Warzone. Favorite villager in Animal Crossing? I think Sprinkles. She was my first one. Sprinkler's Sprinkles. I'm not sure if it's plural. Clayton lore, you guys are all too funny. Valorant, don't play Valorant. For those of you who know, I collect trophies on PlayStation. That's all I do. PlayStation trophies. Don't really get into a lot of the big multiplayer games because the trophies are usually a pain in the ass. Played Bloodborne. Yep, I've platinum Bloodborne, Dark Souls 1, 2, and 3, as well as Sekiro. Am I single? You guys are great. How many trophies I got? 8,000. Far Cry 6 I'm playing right now. I got 160 platinums. Clash Royale I don't play. I just play Clash of Clans. Town Hall 14. Alright, guys, we got to get back to this. Jeez, you guys are hilarious. Duel Me and Bloodborne? Of course. Last time I played PlayStation was in August, yeah. Of course I'm better than Dark Souls than Lobo. He's not that good. Don't tell him, but he's not that good. Hyped for Elden Ring? Of course I am. Stormbound? No, I tried playing. I couldn't do it. So here's a fun story. On a flight, I had to go on a 13-hour flight to South America sitting next to Lobo. You guys want perseverance? He downloaded Game of Thrones on his phone. Like just a text version. It looked like it was in Notepad. 13 hours. He sat there scrolling on his phone. Isn't that crazy? It's crazy. It's crazy. Edmonton or Calgary? Oh, it depends in terms. Oh, let's be honest. Calgary's a nicer city. Like, come on. It's closer to the mountains. In terms of actual hockey, Edmonton, of course. Eng 130 review. Yeah, got to get back to the Eng 130 review. You guys, come on. Back to it. Simple math. We got 0, -4. We got -4. I will do lore later on. -4i. 0 -4. -4j. And then finally 2 - 0 plus 2k. Do position vectors have units? What do you guys think? Do position vectors have units? Yes. Yes, they do. Do unit vectors have units? No. See, you guys got this. This is going to be units of meters. So I say, okay, I have my position vector. I want to convert it to a unit vector. Again, that's the name of the game. What do I need to convert this into a unit vector? Magnitude. See, you guys got this. So I can say, all right, the magnitude of RCB is going to be equal to, it's just going to be the square root of all the components. So we have -4 squared plus -4 squared plus 2 squared. This comes right from your formula sheet, but I think your exam's open book, so completely up to you guys. You guys do all that, you guys will get the magnitude as 6 meters. 6 meters. So now all we have to do to find the unit vector is just take each one of those components in our position vector and divide it by that magnitude. So UCB, like this, is just going to be each component divided by 6. So we have -4 over 6 in the I. We have -4 over 6 again in the J. And then we have plus 2 over 6 in the K. No units. All right, perfect. No units. So now we have this. I now have the unit vector, and I have the magnitude of FC. All right, I have the unit vector and I have the magnitude of FC. How do I get FC in Cartesian vector notation? Again, I have my unit vector. I have the magnitude. How do I get them? Exactly. You just multiply it. So all I need to do is take 300 and multiply it into each one of the terms. So I'm just going to go this term times 300. I'm going to go this term times 300. And this term times 300. That's how I get FC. So I'm just going to come down here and say, okay, FC is going to be equal to 300 times negative 2 over 3. Well, we know that that's going to be negative 200 in the I direction. Negative 4 over 6 times 300 is also negative 200 in the J direction. And then finally, 300 times 2 over 6, or 1/3, we have plus 100 in the K direction. And this will have units of kilonewtons. So step 1 is done. This is where kind of the fun starts happening. We now have FC in Cartesian vector notation. So that's no problem. So I'm going to erase this. We now have FC in Cartesian vector notation. And we know that we want the moment about point O. So I need a position vector. Question for you guys. Come on, you guys are super smart. We got this. Am I going to go a position vector from O to C or C to O? OC, exactly. Now, big brain time. Come on, big brain time. Could I go from O to B? Oh, yes, exactly. So here's the first trick. It doesn't matter what you do. You can cross the position vector as long as it touches any point on your force vector. All right, any point. So what I'm going to do really quick, just to show you guys, if I were to have, let's say this was my line of action of my force vector, like this. If I wanted, all right, I don't want to, of course. Oops. Could I take it to this point over here, way at the top? Yes, I can do it from this point down at the bottom. As long as I go from O to any point along the line of action of my force, I'm good to go. I can do any one. It'll always give me the exact same answer after I cross it. So I'm going to erase this. And I think what I did in my notes here, let's just check. I went from O to C. So I picked this right here. Go from O all the way over to C. So we know that this is going to be a position vector ROC. And we know that since we're just subtracting the origin, we know that this is going to be 4i plus 4j plus 0k. And of course, that will be in meters.
Sorry, I have a question.
Yes, of course.
So why do you go from point O and not from like the first position vector you found?
I'm not sure what like why do I start at O? Sorry?
Yeah, because like we got RBC
Yes.
or CB or whatever, and then why do you choose that position vector for your fish?
So the key is the second diagram over here. If we were to look at this diagram, it wants our forces about point O. So because of that, we know that we have to start at point O and then go anywhere onto the force. That's kind of the big reason.
Oh, okay. That makes sense. Thank you.
If this diagram right here said, let's say instead of O, it had A, well then we start at A and then go to the force. For the cross product, the position vector we use starts at the point we want the moment about, and it goes to anywhere on our force. In this case, we want the moment about point O, and then we just take it to anywhere on our force. In this case, I picked C as the location on our force. So hopefully that makes sense. That's a great question. Great question. So now I have everything I need to do the dreaded cross product. So I say, okay, if I want the moment, and I'll call this moment 3. Again, I'm just using arbitrary names The first case, I put moment 1, second case, moment 2. In this case, I will go moment 3. We know it's going to be ROC cross FC. Just like that. All right. Yeah, so this will be posted to YouTube. This won't be posted to eClass. Now you guys are saying, Clayton, you're being a jackass. You just want the views, right? No. Here's the secret. If I post it to my YouTube channel, the university can't take it down. You know that? If I say something in here that doesn't agree with the university, they could take it down. But then I can't. The university can if it's on my YouTube channel. And you guys are saying, oh, Clayton, you just want the ad money. Here's a secret. Secret number 2. I'm not monetized. None of my channels are monetized. You guys know that, right? I would never monetize it. Why would I monetize it? I get 1,000 views. It's not worth the 60 cents for you guys to make fun of me. It's not worth it. I wouldn't monetize my videos. Unfortunately, you guys have ads. It's unfortunate. It's one of those things that I got an email from YouTube that said, since you're not in our partner program, we have the right to put ads in your video. Okay, whatever. Nothing I can do. I'm not monetized. If you guys want proof, I will show you the YouTube account later. I'm not monetized. Easy way to tell the new account. In order to be considered for monetization, you need 1,000 subscribers. As you guys know, I'm at 250. So I can't even be considered right now. But again, we're going back to this. All right, so if you look here, we're doing the cross product. Now the cross product is fun. Well, not really fun. It kind of sucks. You guys know that. But it's pretty easy once you get the hang of it. We basically have 3 rows. We have the top row, we have the second row, and then we have the third row. The first row is always going to be that IJK. Always. Unless you're doing triple scalar product, but you guys shouldn't be doing that. The second row is always going to be the position vector, and then the third row is always going to be the force vector. It's very important that we don't mix these up. If we mix them up, our answer is going to be different. It's going to be wrong. The cross product is something called skew symmetric. You guys haven't heard of it, I bet. And why would you? It's pretty boring math nerd garbage. So basically what that means is the order is very important. So what I'm going to do is I'm going to say, okay, my first row is going to be I, J, K. My second row is my position vector, ROC. So I come to the top. ROC, and I'll underline it in orange, we said is 4, 4, 0. So I'm just going to come down. We have 4, 4, 0. And then finally, our third row is going to be our force vector, negative 200, negative 200, and then we have 100. So it's going to be something like that. And then this is when I do my fish method. You guys don't have to do the fish method. For me, it just always works. I never seem to forget it. Pro tip, if you guys ever want to remember something, make it controversial. Every time you do that, it never goes away. I saw a question at the top here. Why didn't I go RCB, I think it was. RCB just gives us the unit vector of, this is used to find the Cartesian vector notation of our force. If we want the moment about a point, the position vector has to start at that point. In this case, we want the moment about O. So my position vector has to start at O. And again, I want to remind you guys, because sometimes it's easier, sometimes it's not. You can go from the point to any point on your force. So if I wanted to, I'll do this in blue, I could have went ROB. I could have went. That's completely valid. It'll give you the exact same answer. You can go ROB or you can go ROC. Again, as long as you're going from the origin to your force vector. It doesn't matter which way it works. I just happened to pick ROC. Well, reason why? Well, C, Clayton. Makes sense to me. So I'm going to come down here, and now we're going to start doing the fish method. Or the white sturgeon method, or the goldfish method, whatever you guys want. Yellow perch method. Nice, I like that one. Rainbow trout. You guys are just a bunch of trolls. All right, so what I'm going to do, I'm going to go to my dashed line. What I do in the fish method is I basically analyze each component separately. Use your calculator? Sure, you can use your calculator. Doesn't hurt. Why don't you guys use MATLAB? You guys know MATLAB does cross product like that, right? It's actually a built-in function, cross product. That's a secret. Everyone hates MATLAB, but MATLAB's the best. What's MATLAB? Well, you'll see. You will see. Teach I would, but I don't know calculus. I'm pretty garbage at math, so I can't. So basically, what we're going to do is we're going to find each component of our moment vector. Now I'm going to switch colors here so it doesn't get mixed up. Let's go blue. So if I want the I component, okay? What I do for the fish method is I cross out whatever I want. So I want the I component, I'm going to cross out that column. And then after that, I'm just going to make a fish. That's it. I start at my top left, and I'm just going to come down and make a fish, just like that. That actually looks like the Animal Crossing fish. I'm pretty proud. Maybe give it a little eye, happy face, something like that. And the reason why we draw the fish is because we can trace the components. So again, if I'm looking for my moment vector, M3, and then we're looking at the I component, all we're going to do is go to the path of the fish. I start at 4, and then I come down to 100. So what I'm going to have is 4 times 100. And then when I swoop back up, here's the trick. When I swoop back up, it's a minus sign. So right here is where I have my little minus sign. And then I just follow the path again. I go from 0 to negative 200. So I'm going to go, okay, 0 times negative 200. And that right there, ladies and gentlemen, is my I component. That's it. So what I'm going to do is I'm going to erase this now. It gets pretty messy. And I say, okay, I have the I component, but remember, this is a moment vector. It's going to have 3 components. So what we're going to do, and I'll switch colors again, let's go green, is I'm going to say, okay, now I want my J component. So what I'm going to do is I'm going to cross out that column that I'm interested in. I'm just going to draw another fish. I start at the top left, so I go from 4 to 100, up from 200 down to negative 200. I'll switch this back to a solid line. So for the J component, again, the only trick is I take the negative outside. And I know this caused a lot of confusion in the Discord. Clayton, why is that negative? Well, here's the truth. A lot of professors will rearrange terms to make that positive outside. But here's the secret. In Math 102, which you guys will take next semester, linear algebra, this is the actual proof. The actual proof, all right? Don't tell the professors. This is the actual proof. So if you have a professor that gives you something and this is already positive, they're showing you the simplified proof. If you guys want the pure stuff, the good stuff, this is the good stuff right here. So I'm going to get rid of it. This is going to be negative. And again, I just go from my fish path. I go from 4 down to 100 in this case. Again, when I swoop back up, it's the same as going minus, so minus. And then I go from 0 over to negative 200. 0 to negative 200. I'm going to over-explain it this time, and then next time we do cross product, I'll go a lot faster. So that's our J component. I'm going to erase everything, and then we're going to move on to the next one. Once you guys do this once or twice, you just do it in your head. You don't actually need to draw the fish, which is pretty nice. Drawing the fish every time would be a lot of work. All right, so now our last component, of course, is going to be our K component. So I'm going to cross out that column. I'm going to draw a fish on the remaining items, so these ones right here, and then I'm just going to trace the path of the fish. Come down here, I'm going to go plus. We start at 4. We go down to negative 200. 4, negative 200. Then we go minus. We check our other components. We go from 4 to negative 200 again. 4, negative 200, and that'll be in the K direction. So that's going to be all our components. Then you can just throw it into your calculator. But again, you guys can just throw it into your calculator right off the bat. It's whatever's easiest for you. I just want to show you guys so that if you guys do want to do it by hand, you guys have that option. I don't want to be that guy that just says throw it into your calculator. Never really works out too well on an exam if you're banking on throwing it into your calculator. So M3, if we were to do all the calculations, it's 400i minus 400j plus 0k. And it's going to have units of kilonewton meters. Now, the nice thing that we can see here, and this is the beautiful thing about cross product. The beautiful thing about cross product. This is why it's sexy. Look at the J component. It's negative. What that means to us is the cross product takes into account signs. We don't have to worry about signs. Remember, in this moment couple number 1, I actually had to take my pencil. I had to look like an ass trying to do this to figure out the sign. Here in cross product, it takes account all my signs. I don't have to do a single thing. So that's the nice thing. Now you guys may be saying, Clayton, I just want to keep throwing it into my calculator. I say, okay, that's great. Have fun. What happens though when one of the parameters is unknown? Let's say instead of a 4 here, you have alpha. What then? Uh-oh. This is why I like to teach it, so that if you guys are ever in a case like this, which could probably happen, you'll see it in a later example, you guys will know actually how to calculate this. So I'm just going to take it away. We're going to go back to 4. All right. So now we're at a very special time. Special time. We have M3, we have M2, which is 0, and then we have M1. Basically, we have all the moments created by each one of these forces. If we look over here, it wants the force couple system. Basically, it wants the resultant moment. Resultant moment. How do we get that? What do I do to my moments to get my resultant moment? What do you guys think? What does chat think? Add. That's it. Just add them together. It seems like a trap, right? Like if you just had to add something together in Math 100, you know you're doing something wrong. Math 100, you feel like a dumbass of just adding them together. If we look here, though, that's all we need to do. It's that simple. It's one of those psychological things. You think, no way, it's that easy. It's that easy. Once you have all the moments, and I want the resultant moment, all I'm doing is adding them all together. So resultant moment, which I'm going to call MR, is just going to be M1 plus M2 plus M3. That's all it is. Going to be those 3 added together. What's nice for us is we know that M2 was 0. So I'm just going to cancel that out. So I just have to add the other components together. Basically, we have M1, which was negative 100 in the I direction, plus 0 in the J direction, plus 0 in the K direction. And then all we need to do is add this to M3, which we have above as 400I minus 400J, and then plus 0K. At least that's what I got anyway. So what happens is when you add these components together, you see that MR, I'm just going to scroll up a little bit, hope you guys don't mind. My hand was running out of room. This is equal to 300I minus 400J plus 0K. Kilonewton meters. It's really boring, but it works. All right, if you don't mind, can I see how you found M2? M2 was 0 because the two forces basically canceled each other out. So M2 came from these two 120 kilonewton forces, and it canceled out because they create moments, but again, they cancel each other out. If I have pencil, my little Apple pencil here, and I were to apply 5 kilonewtons to the left, it tilts counterclockwise. If I were to apply 5 kilonewtons to the right, it goes clockwise. So if I were to apply both of those at the same time, it's just stuck there. It doesn't actually rotate. There's no moment because they cancel each other out. So hopefully that works. If all else fails, you can realize that they are a moment couple, but the perpendicular distance between them, again, the key is perpendicular, is 0. There is no distance separating those two forces. They are exactly the same. So you can throw that in as 0. If one of the forces is different, would you have to calculate them both independently? Yes. Doesn't that suck? That was one midterm. I didn't include it because it's really boring. But there was one midterm where it was this scenario, but one of them was a little bit off. I think it was like 50 versus 55. If that's the case, you're screwed. You got to do them separately, which really sucks. Do you think they'll give us a wrench? It's been confirmed. No wrenches. That came straight from, I think I saw it in Maha's Discord. There's no wrenches on the exam. Yeah, right? Awesome. Perfect. So that's how we get the resultant moment. Now the resultant force is just going to be the same thing. Resultant force. All we need to do is just take all of our forces and add them together. Now this is actually a really funny one. So we're going to go up here. Again, resultant force, I'm just going to zoom in on the diagram, is all of our forces added together. I'm just going to erase all these things. Yeah, why not? I've come too far. Let's look at these two forces. I have 25 kilonewtons going up and I have 25 kilonewtons going down. So nothing happens. If I were to pull this up 25 kilonewtons and pull it down 25 kilonewtons, I'm where I started. So that's 0. So these two forces cancel each other out. Same thing with the 120. If I were to take 120, pull it to the side, and then I take the other 120, pull it to the side, these two also cancel each other out. Does this one cancel out, though? Is there something that's going to cancel out FC? 9, exactly. So the resultant force in this case is actually just equal to FC. So I'll zoom out a little bit. We come down here. We know that our resultant force, FR, is just going to be equal to FC. And what's nice for us is when we did the moment, we already calculated it. So we know exactly what this is going to be. If I scroll up, we had it as negative 200, and positive 100. So negative 200 in the I, negative 200 in the J, and then we have positive 100 in the K. And this will be units of kilonewtons. Fun fact for you guys. Is 100 kilonewtons a lot of force? You guys don't know this. But is that a lot of force? You guys are saying yeah? The concrete beam in ETLC. Most of you guys have the lecture hall in ETLC, right? The concrete beam above you. If not, just think of CSIS. That CSIS L2, same thing. The concrete beam above you, holding that roof over your head. Do you think that it's less than 100 kilonewtons of force on it or more? At least 3 kilonewtons. I like the way you think. It's definitely more. It'll probably have maybe 200. It's not crazy amount. Probably about 200. So those are actual structural loads. If you guys have 200 kilonewtons, that's structural load. I could hold the beam up. I can't. In the structural lab, I actually just about got destroyed because I tried to lift a steel beam but couldn't. Steel's heavy. Steel is really heavy. It's crazy. That structural lab that you guys see, that's all demolished right beside ETLC, I did a lot of my experiments in there. So I played around with a lot of stuff. I can't lift steel beams. No, they're heavier than they look. All right. Quick question. How we take the moment if B and D weren't both... that's a great question. So you have a couple of options. Let's say that this 120 over here was by itself. Let's say everything else was gone and it was just that 120. You can do cross product. That's a secret. They don't really tell you that. You can do cross product. All you have to do is find the position vector from O all the way up to B, and you can easily express that force in Cartesian vector notation because it just has a y component. So it would be 0, negative 120, and 0. You could do cross product. Another thing to note, and this is kind of the mega secrets, is that 120 is in the YZ plane. So any moment created by 120 is going to be along the x-axis. Hopefully that makes sense. It's the same in 2D. In 2D, if I have a moment in the xy plane, all of my moments are about the z-axis, and it makes sense. Pretend that this ruler here, it's transparent, so I know it's not the best job, but let's pretend that this was my 2D plane, and I were to put a force going downwards. You see how this spins along the axis defined by my pencil. My pencil comes out of the page. Look like Pinocchio or some shit. But that's basically what it is. All the moments are going to be the axis perpendicular to the plane that they're in. All right, so that's question A. We're taking our sweet time here. It's been an hour. Oh, maybe we won't get through all the questions. Maybe we'll have to do another review session. So that's A. That's 5 marks. So that's half the question. Half of the question. That's good to go. Part B. Determine the angle between FR and MR. Determine the angle between FR and MR. So if we look here, this is basically what we got. I'm going to switch to blue so you guys can see what exactly I'm talking about. This is now the situation that we have. This is our new system. And it wants us to determine the angle between here. Question for you guys. Question for the chat. Do I need to convert one of the forces into a unit vector, or do I have to convert the moment into a unit vector? Can I just dot product a force and a moment vector? No problem? Are you serious? Really? Are you willing to bet your grade on it? I see your names. I can keep track. No? Yes? Maybe? That's the secret. It doesn't matter what the vectors are. You can always dot them together. So that's the other secret. If you guys ever see angle, ever see angle, you should be thinking about dot product. Every single time. So what we're going to do is we're going to come down here at the bottom. And for part B, we'll stick with blue. Blue's a nice color. So for part B, blue, we know that cosine of theta, the angle between two vectors, is always going to be equal to the dot product of the two vectors. So we're going to say FR dotted with MR divided by the magnitude of both of those vectors. So we're going to have the magnitude of FR, and we're going to have the magnitude of MR. It looks bad, but if we look above, we have MR right here. We have FR right here. The magnitude of FR, we actually already know what that is too, because if we scroll right up to the top, and I have it circled in red, so I'm going to circle it in blue, we know that FR, which is FC, is just going to be 300. The only thing that we need to do is figure out the magnitude of MR. So I'm going to come down here and say, okay, the magnitude of MR is going to be just the square root of all the components squared. It's the same formula no matter what vector you have. So it's going to be 300 squared plus negative 400 squared. We don't need to worry about the k component because it's 0. And once you do that, you get that it's equal to 500.
ماما خلص رح استعمل الباندرات وهيك.
I don't know how to mute, so that's going to be on them. All right. So now we have absolutely everything we need. Now, cross product, we've established. It sucks. This is dog water. No one wants to do cross product because it requires some work. If we were to come down and look at dot product, don't worry, it's easier. All right, that's the nice thing. It's easier. The dot product, all we do is take the components and multiply them together. Like, I know it looks dumb, but this is all you do. Take them, multiply them together. So if I were to go FR dotted with MR, what we end up getting is the first two components multiplied by each other. So I'm going to scroll up so we can keep them. So this would be 300 and negative 200, the 2i components. So we have 300 and we have negative 200. And then we add them to the next two components multiplied by each other. So we have negative 400j and we have negative 200j. So we have negative 400 and then we have negative 200. Our final two components, well, one of them is 0 in the moment vector, so I'm just going to go plus 0. So what I'm going to do is throw all of this into the calculator, and I get that this is equal to 20,000. From there, I say, okay, I have everything I need for my formula above. I know that cosine of theta is going to be equal to the dot product, so we said that this was 20,000, divided by the two magnitudes. So the first magnitude was 300, the force, and then the second magnitude, which we calculated, was 500. You throw all of this in, and you get 0.133 repeating. Now after this is where the secret comes in. Another secret. This is why I can't post it to the U of A channel. They don't like it when I say secrets. They think I'm giving away all the exam tips. Because I am. But this isn't a secret that has to do with professors. This is a secret to do with you. Don't let your calculator be in radians. And this is what scares me. As soon as you guys said, I have a math test tomorrow, I'm thinking, uh-oh. Typically what happens in math is you do everything in radians. So make sure that after your math test, I know you don't get a calculator, but let's be honest. If you guys are doing it at home, half you are using a calculator. You're not fooling me. I've seen people write exams at home. Everyone uses it. In person, whoa. Okay, that blows my mind. I didn't think the university was allowed to do that. In person, wow. All right, you guys win. Rest in peace. F in the chat for you guys. Hold on. I don't want to message someone directly. How do I message everyone again? Everyone? Here you guys go. From me. That's brutal. I almost thought I slurped my pencil for a second. I gotta keep track of which is which. Long story short for this, make sure that your calculator's in degree mode. Because after that you can say, okay, theta is equal to the inverse cosine of 0.133, and you'll get that the angle between the two is 82.3 degrees. 82.3 degrees. Not too bad, right? As long as you have them, everything is fine. We're going to move on to the last part. So let's do this part in pink. Part C. It's only worth 3 marks, right? Like, how hard can it be?
Ease.
This is when they tell you just to go screw yourself. Recall that the resultant moment has 2 components. As soon as you read that, because you know you're in for something gross. Resolve MR into 2 components. The parallel component and the perpendicular component in the direction of FR. So basically, we're doing vector addition in reverse. What this is saying, and I'm going to erase it, I'm going to use this. We're going to zoom in here. We have this case now. We have our moment, we have our resultant force, and it's basically saying that this moment, let me decrease the thickness there. Let's see how this goes. Something like this. So this resultant moment can actually form a triangle, and it has 2 components. This one right here is going to be MR perpendicular, and then we have a component like this, which is MR parallel. I'm hoping you guys see this. This is what the question's asking. We have MR. How do we get those 2 components along F? What do you guys think in the chat? How do we get MR parallel? How do we get this bad boy right here? Projection. Exactly. Dot product through projection, it's the same answer. That's it. All we need to do is project it. Oh, and I accidentally locked my screen. Give me 2 seconds. Does this go back on? Oh, I'm seeing myself. Damn, am I ever white. Holy crap. I don't even have like a brightness thing on. It's pathetic. All right, how do I go back to Zoom? Share content, share my screen. Perfect. I gotta flip to notability really fast so you guys don't see the secrets. All right, start broadcast. I have no idea. Sharing screen, wonderful. Perfect, that was quick. All you guys saw was my Monopoly. I had to switch it to a different page. All right, so all we're going to do is find these two components. Now, the nice thing here is if I have a vector, all right, it could be any vector, and I want to project it in a direction, all I need to do is dot it with the unit vector defining that projection. So if I want, oops, that's the highlighter. If I want this MR parallel, all I need to do is take my vector, in this case MR, and then dot it with the unit vector defining the line. The line here we know is F. So I'm going to say the unit vector of F. 405, ask him in inch terms. He can bench our grades? Bench? Does it look like I go to the gym? I spend my time doing Lego, video games, things I'm not allowed to say on camera, and that's about it. So, no, I don't go to the gym. Why would I want to go to the gym now? It's just gross. Everything in there's sticky. Whoa, bro. Whoa. Got you guys all crazy and upset. Back to what we're doing. You guys are off topic. You guys are literally Twitch chat. Literally. All right. So this is our formula. The question is, if I were to look at this, I'm going to underline in blue. We have our resultant moment. That's nothing. What is this, though? How do we find the direction of FR? Does M parallel meaning finding the moment parallel to FR? Yes. Moment perpendicular means the moment perpendicular to FR? Yes, exactly. So what is that unit vector defining the force vector? We have our resultant force. So if we have our resultant force, can we find the unit vector of it? FR divided by the magnitude. Exactly. But here's the trick. Gotcha. No one said this. If FR is equal to FC, remember, we've already concluded this. Well, then wouldn't our unit vector be the one that we've already calculated? Oh, I got to change the thickness back up to normal. Is this the thickness? Oh, that's too thick. Well, is there ever too thick? Oh, that's still too thick. Never mind. All right, third time? Third time? All right, that's better. That's better. Perfect. So we already have what it is. Remember, before, we had FC as a magnitude, and we had to find it into Cartesian vector notation. So we already found this unit vector. It's negative 4 over 6, negative 4 over 6, negative 2 over 3. So I'm going to come down here, and what we were doing it in pink, right? All right, here we go. We're doing it in pink. We said that our moment perpendicular, moment resultant parallel is equal to our moment vector dotted with the unit vector of that resultant force. We have all of the components. Why did you use the unit vector CB? Great question. Because we said that since all the other forces cancel, this FC right here, I don't know what happened, hold on. Technical difficulties. FC right here, come on, work for me. All right, there we go. FC is equal to our resultant moment FR. So technically, our resultant moment starts at C and goes to B. It's because all the other things canceled out. If you wanted to, and this was a different scenario, you can always just find the magnitude and then divide by it. It's just more work. But you can definitely do that. I'm always trying to find the shortest way because I'm lazy. Which is why it's funny you guys think I went to the gym. All my videos I talk about how to do things the laziest possible way. That's everything in life. It's not just teaching Engine 130. Everything. All right, so we have everything we need. The dot product, again, is just multiplying the components. MR, if we go up, was 300 in the I direction. Oh, sorry. A little bit confused with part C. All right, no problem. We'll go up and just check, or just go back to it. I zoomed in. It said that we have a resultant moment, and we have a resultant force. We know that vectors can be broken up into components. This is the exact same as this. Imagine you had a vector in 2D. All right, vector in 2D. Something like this. 2 dimensions. If I were to ask you guys, what is the x component? You guys know exactly how to do that. You guys laugh at me. Clayton, it's too easy. Give me something harder. If I were to ask you guys, what is the perpendicular component or the vertical component? Again, you guys know what that is. That's exactly what we're doing here. MR parallel is going to be the component along the FR axis, and then the perpendicular one is perpendicular to the FR axis. That's all we're doing. If you have more questions, just email me after and I can help you out. So again, all we're doing for dot product is just multiplying them together. Where's my moment vector? So for the moment, we have 300, negative 400, and 0. So we go 300 times negative 4 over, or negative 4 over 6. Again, this comes from that unit vector. Plus, in this case, was it negative 400? Yeah, negative 400. Times negative 4 over 6. Then we have plus 0, because the moment component is 0. All right. Yeah, we only went through one question. Yeah, so we'll probably skip a question. One of the questions is very similar to this. I'll show you guys the juicy question after. Or the juicy question. So if you guys were to throw that into your calculator, what you end up getting is 66.66 repeating kilonewton meters. Is that my answer? No. That's the trick. If they wanted the magnitude of M parallel, that's our answer. You guys got it in chat, so you guys are too smart. If I were to go back up to the question, though, it says find the two vectors. But it's not too bad, because if we were to look at it, basically, we know, scroll in here, we now know the magnitude of MR parallel. So that's the first part. Remember, a vector is a force times a direction. We already have the magnitude. All we need is the direction. But we have the direction of FR. It's just that unit vector again. So all we need to do is come down here, all the way to the bottom, and say, okay, if I want MR as a vector, MR parallel, all I'm doing is taking the magnitude of MR, and I'm going to multiply it by the direction. So UFR. So all we have to do is take that 66.66, multiply it into that unit vector that we had above, and we get negative 44.4I minus 44.4J, and then plus 22.2K. And then this will be in kilonewton meters. Sound good? But remember, this is just half of part C. Part C says, okay, you found MR parallel. What about the perpendicular one? The nice thing for us is we had a triangle. We know that MR, the complete resultant moment, is equal to MR parallel plus MR perpendicular. It's a triangle. It goes back to parallelogram rule. No one likes parallelogram rule, but we have to use it in this particular case to get this identity. So if I were to rearrange this, MR perpendicular is going to be equal to MR, which we know, minus MR parallel, which we also know. So if this is the case, you will find that MR perpendicular is going to be equal to, where did I write it down? Right here, 344 in the I direction minus 356 in the J direction, and then minus 22.2 in the K direction. Kilonewton meters. Lots of fun, hey? Lots of fun. What if we had to solve for the perpendicular in this case? How would you solve for the unit vector of the perpendicular case? Sorry, are you asking about the unit vector of MR perpendicular? So you can find it by finding the magnitude of perpendicular and then dividing by it, but that's too many steps. I can't see them ever doing that. That'd be way too mean. You always have to find the parallel one first using dot product, and then you go to perpendicular. And then you can modify it further, but again, that's a lot of work. So that's question 1. So imagine my surprise when this was my first question. This was my midterm. That's my first question. All of that was 25% of the midterm. Just 25%, all that garbage. Lots of fun, hey? Yeah, exactly. And I'm thinking, okay, I can probably answer some of A, maybe B, but I'm not even going to try C. So I answered A, I answered B. I remember this. I answered A, answered B, and I thought I'll save C for later. Surely C has to be the worst, right? The midterm can't be harder than this. Like, that's just too much work. And then they hit me with this. This is a moment question. Isn't that crazy? This is question 3. I thought I was done with moments. Then they smack me with this. Let's take a little read, shall we? A little trip down memory lane. I remember in Lister going to the washroom after the exam thinking, holy shit, that was not fun. Because of this one. You know what the worst part about exams are? Is when everyone at the end is talking about it. What'd you get for C? What'd you get for C? I didn't get anything, but I had to pretend like I did. You don't want to be that kid that didn't get anything. So I said, yeah, I got 1. Everyone, oh really? I didn't get 1. Yeah, no, I didn't do good on the midterm. Have I ever had to retake a class? No. I got close. Final year, engineering law. I got a C. I didn't try at all for that course. Engineering law isn't fun. I thought this was an eng class. Exactly. Oh, you'll see. All right, so let's go through this question. What I'm going to do is I'm going to go through this question. I'll upload the PDF of the other question I solved so you guys can look through it. It's from another midterm. And then we'll probably call it a night because you guys have stuff to do. You guys got math. I just got to find my stuff. And yeah, I'll upload the PDF. If I knew that you guys weren't getting reviews, I would have done this earlier. So we could have done multiple sessions. Multiple sessions. It's nice meeting you guys. I get the occasional crude comment on my YouTube videos from you guys, but I don't really get to meet you, so this is actually pretty nice. I snuck into Carlos or Dr. Lowell's class to see you guys. No one could recognize me. I put my hat on, I put my mask. No one can see me. Can we have a review every 10 days? I tell you what, I was prepared for you guys to ask me for a final review. A final review. Do you think I can do a final review? I would go to Maha's class, but I actually teach during that time. I teach during Maha's class. Right beside Maha's class, actually. Yeah, I teach 8 a.m. Final review. All right, and I can prepare. So how about this? Here's the deal. Everything in life is give and take. Everything in life is give and take. Don't let anyone tell you otherwise. Nothing's for free. So here's what I'll do. I will do one final question for every 100 subscribers I have by the time the final rolls around. On my new account, not the old account. Who cares about the old account? I don't even know why it's still getting subscribers. So right now we're at 250. So right now you guys have 2 questions. And I put 100. You guys are thinking, Clayton, that's kind of a jackass move. 100 subscribers? Well, I learned something the hard way. You don't mess with first years. You never mess with first years. When I taught this class in 2019, I thought, okay, you guys are going to probably do fine. But I told them, I said, if you guys do amazing on the final, or no, midterm. If you guys are 5% above the other sections, impossible, right? Like, impossible. I will buy you pizza. Pizza for the entire class. 200 kids. And they did it. I was going to buy them pizza anyway because I felt bad because they were so stressed, but they did it. First years can accomplish anything if they put their mind to it. So I always try and set the bar as high as possible so I don't overpromise things. If I were to say like every 25 subscribers, I'd be doing every final in the history of Eng 130. I don't have time for that. You guys don't have time for that. Exactly. That pizza bill was like $900. Never forgot about it. It was right before reading week, actually. It was kind of nice. Had a little pizza party, and then we went home and enjoyed reading week. Yeah, it was great. First year power hour. All right. Subs went up by 40. And not, yeah. If this wasn't COVID, I'd probably give you guys a pizza party. Let's be honest. That's what you guys should do. Get a pizza party. But I know that the university would be up my ass if I tried to do a pizza party during COVID. They don't need to know. They know everything. They know everything. Yeah, there's no hiding from the university. It didn't take very long for my videos to get flagged down and censored. So the university knows everything. And it's good. The university makes sure that everything is high quality. So you got to respect them for that. I'm just not high quality. That's the difference. My standards are very low. That's the secret to midterms. All right? You listen. If you guys want to take one thing from this, here's a secret. To midterms. Not just Eng 130. All of your midterms. And everything else. Lower your standards. Lower your standards. Once you do, everything is great. Applies to everything, not just midterms. Anything. Dating life, lower your standards. Exactly. Okay, yeah, see? Raphael is going to have a good night tonight. You can tell. Never. Yeah, I'm just playing around. You guys are the future engineers. You guys are doing amazing. Amazing. It may not look like it when you look at your midterm marks, but you're amazing. Okay? Think about high school. Think of all the friends you had. How many of them are in a top engineering program right now? Sure, some of them, but not all of them. You guys are in one of the top engineering programs in Canada. You guys are doing amazing. I'm proud of every single one of you. Right? I'm proud of every single one of you. I feel like Steve from Blue's Clues. Never forgot you. I'll be in your graduations, cheering you guys on. Right? I promise. You guys are doing great. Now let's get to the fun. Every time I do a review session, I include this question. And every time I always say the same thing. Same thing. I say, this is the last time I'm doing this stupid question. It always gives me PTSD. You know, Vietnam flashbacks. This question. Something about it. Just terrible. But then I realize how much you guys love review sessions, and I have to do it again. So here we go. Doesn't look like a moment question, but this is a moment question. A homogeneous square plate with a total weight of 4 kilonewtons is supported by 4 cables as shown in figure 3. What homogeneous means is that the weight is distributed evenly throughout the entire plate. It's not heavier on one side, anything like that. Distributed evenly. It says these 4 cables are connected to a spring. A moment question with a spring. You just know this is going Fe at point E. If the magnitude of the moment created by the tension in cable AE, so if we look down here, this is AE, over here, around point F is 2 root 2 kilonewton meters, calculate the unstretched length of the spring. O is the geometric center of the plate, and the coordinate points of E is 0, 0, 1 meter. Neglect the thickness of the plates as well as the weight of the cables, and neglect the elongation of the cables. You guys ready for this? I'm not ready for this. This one sucks. So basically, in a question like this is what I recommend. If you guys ever have a question and you're not really sure where to start, personally, I just like to make a diagram and try and figure out, what do I know? What exactly do I know? So if I were to come down here and say, okay, I have a point right here. And we know right here from above that this is point F. This is the top of the spring. I know right below this point, I have point E. And they are connected via a spring like this. What else we know right from the question is that E right here has coordinate point. It says it in the question. It's pretty sneaky, but it says this right here. 0, 0, 1. So I say, okay, I come down here. We have coordinate point E, 0, 0, 1 meter. The other thing that we have is that we have tension in the cable AE. So if we come down here, we say, okay, we know that we have a force vector right here, which I'm going to call FAE. And if I were to kind of extend this, we know that this goes to point A. I come up here really quick. I can see that point A right here is located at a distance of, well, if we were to look at it, going along the x-axis, this distance right here, well, we know it's going to be the 4 divided by 2. So we know that this is going to be 2. If we were to look at the other distance going along y, we can see that it's actually backwards by 2. So negative 2. 2, negative 2, and 0. So this is what we know so far. Question. Clayton, do you use mathematical induction after first year? No. I've never seen mathematical induction. I remember mathematical induction because everything in Math 100 was easy until that thing hit us. That hit like a brick. Mathematical induction. Sucks. No one likes mathematical induction. So this is what we know. So here's kind of what we're after. What we want is the unstretched length of the spring. So I'm going to say that this L0. The last thing that we know for sure is the moment created. Now I'll highlight it here. The magnitude of the moment created by the tension in the cable AE around point F is this. So that tension cable creates a moment about F of 2 root 2. So I come down here, I say, okay, on the side, as a side note, RFE cross with FAC, or AE, I guess, is equal to a moment vector, and the magnitude of the moment vector, starting to look like garbage, isn't it? 2 root 2. Not very fun, is it? Not very fun. Yeah, it's gross. But if we look here, we can start working backwards. Because if we were to look at the stretched length of the spring, all right, the stretched length, L0, or the unstretched length, whatever you want to call it. Again, we want this distance right here. Actually, let me switch colors so to make it more vivid. We want this distance right here. We don't know that distance, right? We don't know that distance. But tell me this, guys. Tell me this. If I knew the coordinate points of F, could I know that distance? If I know the coordinate point of F, can I determine that distance? Exactly. And if we look up here, we can see that F is just right above E, right? It's right above E. So we know that F right here is going to be 0, 0. Again, it's right above E, but we don't know how much above E. So what we're going to do is we are going to go alpha. And this is why doing the cross product in your calculator, it's fine, but you definitely want to learn how to do it by hand. Because as we're going to see, we now have an unknown that we're going to need in the cross product. So that's going to be the trick. That's going to be the trick. This right here is going to be the key to the solution, crossing them together. Remember, I said if we ever have a moment, we have it, it's good to go. And we want to work backwards to find a position or a coordinate point, something like that. We never try and manipulate the cross product, right? The cross product will manipulate you. Don't let that happen. What we do is we carry out the cross product regularly and have it as a variable. All right. So if we look here, this is what we're doing. We're basically doing this cross product right here. Number one problem that we have, we need the force vector. We need FAE. Question, 379 divided by 100 is 2.5. I don't even know what this talks about. I'm not sure what you guys are doing. Maybe a different class. Oh my gosh. 379 divided by 100 is 2.3? How does that work? If it's at 380, then I'll round up to 4. You guys got 4 questions so far. You guys are just great. Question for you guys, and I thought about this, but again, this was last minute, putting things together. For the final review session, the final one, would you guys want it in person? Oh, yeah. All right. So let me talk to the faculty and try and make that work. Of course, don't worry. I would have a separate one online for people that cannot attend. I wouldn't shaft you guys like that. That's a great way to make students hate you. Have an online or an in-person session and not record it. Oh, I could just imagine. That'd be worse than the Rickroll. I got all you guys. I could tell. I was so excited. I was so excited. If you guys go watch, what is it? Lecture 13 of the class I teach. I talked about it. I was laughing the whole lecture. And they said, why are you laughing? I said, because I got the Eng 130 kids. I gave them a link that's garbage. Actually annoyed? Why are you actually annoyed? Here's what happened. If I want to post a video on eClass, I want to post a video, I need to have a URL. What I wanted to do was put a placeholder in so that everyone can find it on eClass. Just so that when this video does go live, everyone's happy. That's all I wanted. A placeholder that everyone can see, that when the video goes live, they can all watch it. But again, I needed a URL. I didn't have the video ready. We're doing it right now. So what do? I picked the best URL I could find. It made you guys happy. See? Can we get pizza? All right. Let me think. I can't ask anything from you guys. The only thing I can think of is subscribers, but even that doesn't matter because, again, I'm not going to monetize. But let's say if there's 1,000 subscribers, we will do a pizza party in person. No sub-bot. What do you mean sub-bot? Get out of here. Badass. No, trust me, just getting in trouble by the faculty. But I'm not teaching Eng 130, so what can they do? Take me out of my section that doesn't exist? All right, back to the question. There's students here trying to learn. If you guys want lore, we can meet up sometime. No, don't go look at the lectures. Those ones aren't censored, and I don't want them to become censored. Stay away from my continuum mechanics lectures, please. All right, back to here. So this is going to be the key here. Because if I know that alpha right here, and let me go to a different color. If I know alpha, I can determine the length of the spring, and then I can use my spring constant to find the original length, right? Like, that's no problem at all. So the question is, how do I get alpha? Well, we're given some information about the moment, so I'm going to check the moment. We're given information about the force, so I'm going to check the force. And our only unknown is going to be in this position vector right here. Don't tempt me. I've thought about Lego reviews. You have no idea. In Maha's Discord, I sent them my build soon wall. It's actually right there. You guys probably can't even see it. I can't see the webcam. I'm not sure what you guys see. There's my degrees. And then I got all this. That's just what I would need to build soon. The closet behind me is full of even more stuff. Can't do it. Take too much time. Back to this. So what we're going to do is we're going to do this cross product. If we want to do the cross product, we need our force in Cartesian vector form. UCS Millennium Falcon? No, I still have that in its shipping container. Like the shipping box that Lego sent it. I'm not taking that out yet. Vlogs? What's my vlog? I go to school, I teach a lecture, I eat Panda Express, and I go sleep. Am I Danish? What kind of question is this? Not rich. Not rich. Just an expendable income is the word. But that's just it. I got that in Maha's Discord. I didn't answer it, of course. But it talks about Clayton. You got money. You got money. Guys, you're going to have money. Isn't this why we're becoming engineers? To get the money? No? Why are we becoming engineers? For the fun of it? Have you ever had to deal with people in industry? That's not fun. For the ring? What's so special about the ring? For the girls, you're in the wrong profession. Here's the ring. Isn't that nice? For the ring? You can click it on stuff. I take this ring everywhere and I scrape it on things. When I went to the Roman Coliseum, carved my initials. I'm at the ring. Big Ben, all that fun stuff. Disneyland, to make fun of arts. You don't have to be an engineer to make fun of art students. Just make fun of them because they're art students. You don't really need a lot. You guys will learn to hate the ring. You know why? Because it sucks to write with. Which is ironic because the whole point is it's supposed to be your ethical while you're writing. But I'm too scared of scratching my iPad with it, so I never really... I never use the ring. I keep it as a nice token. All right, back to the question. No more. I'm going to just take away chat. Chat's going down. All right, I actually can't see chat anymore because you guys are distracting me. So we need FEA in Cartesian vector form. So we say, okay, we have FEA, and it goes between 2 points. So the first thing that we want to do, if we want to force in Cartesian vector form, and we know 2 points, is we want to create a unit vector. Again, FEA, oh, that's a terrible color. Let's switch it. Let's go red. FEA, oops, not A, EA. Oh, EA, that'll trigger all the gamers out there, is equal to the magnitude of FEA multiplied by the unit vector, EA. Now, since we have those 2 coordinate points, we have E and we have A, we can find the unit vector. So we're going to use a position vector EA, which is equal
That's
to
AE on the paint.
Pardon me? Sorry?
You have XAE written down
AE.
above.
Oh, yeah. Sorry. EA. You guys have seen all my mistakes. I get so many comments on those old example videos. That's why I didn't want to post them. They're filled with little typos. And then everyone gets pretty upset when they find one. Clayton, you did this wrong. Yeah, but it's pretty obvious that I'm just an idiot. All right, so we're going we're going A minus E, because again, we start, actually no, it should be backwards. Yeah, we're going from E to A, so we go from A, yeah. So we're gonna have 2, negative 2, 0, minus 0, 0, 1. So this, of course, is going to be equal to 2i minus 2j minus 1k. And it's going to have units of meters. So far, so good. Nothing too crazy. We know that once we have the position vector, we can find the magnitude. So REA, like this. And it's just going to be the square root of all the components squared and added together. So of course we are going to have 2 plus negative 2 plus negative 1. And I guess all these are squared, of course. Don't forget that. Put this over at the end. And you get that it is 3 meters. So now all we need to do to find the position, or sorry, the unit vector EA, we're just going to divide each one of the components, and by components, I mean these components in our position vector, so 2, negative 2, and negative 1. We're just going to divide each one of them by 3. So we're going to have 2 over 3 in the I direction, minus 2 over 3 in the J direction, and then finally minus 1 over 3 in the K direction. You guys are going along, you're thinking, Clayton, baby stuff. It's not too bad so far. But now is where all the fun comes in. If we look here, we can find our force vector in Cartesian vector notation if we know the magnitude and we know the unit vector. All right? Easy. We come down here, we say, Clayton, got the unit vector. What are you talking about? Piece of cake. So I'm going to unhighlight this because that's taken care of. What is the magnitude of EA, though? What is the magnitude of EA? Let's go up to the question. It doesn't say what it is. It says that our plate is 4 kilonewtons. Our plate is 4 kilonewtons. But it doesn't say what EA is. And this is when you have to use the special hint. A homogeneous plate implies that the center of gravity for the plate is at the geometric center. This means the magnitude of the Z component and the tensile force is W over 4. So we know from the hint that FEA, specifically the Z component, is going to be W over 4. The weight at the top here was given as 4 kilonewtons. So 4 kilonewtons over 4, we know this is 1 kilonewton. The first trick that'll get most students is they will think the magnitude of FEA is 1 kilonewton. It's not. That's the trick of the Z component. So basically, if I were to come down here and I were to look at my Z component, we know that in general, FEA, if I were to multiply the magnitude into it, into the unit vector, we get 2/3 of FEA in the I direction, minus, and I know I'm not putting the magnitude signs, but that's okay, FEA in the J direction, minus 1/3 of FEA in the K direction. And we know that this component, I'll switch colors, this last component right here, this one is equal to the -1 kilonewton. I didn't put -1 above because we all know it's going downwards, right? Weight is going downwards. So basically what this means is that 1/3 of the magnitude of FEA is equal to 1 kilonewton. I'm going to pull chat back up, and this time behave. Behave. I get way too sidetracked. I have no idea. What is my magnitude FEA? Cole, you were way too quick. You read my mind. You knew exactly what I was going to say. 3. So that's the trick. It was not 1. If you guys used 1 in this question, everything else just goes down the garbage. That's where everything gets really sneaky. So we now know that FEA, or the magnitude of it, is actually 3 kilonewtons. And now that we know that the magnitude is 3 kilonewtons, we can multiply that by the unit vector to get our force vector in Cartesian vector notation. So FEA is equal to, it's going to be 3 times, what is it, 2 over 3? So it's going to be just 2i. And then we got 3 times -2 over 3, so minus 2j. And then we have, what's the last one? -1 over 3 times 3, -1, k. Kilonewtons. A lot of fun. Where did the 1/3 come from? It is the component of the unit vector. Great question. It's that component of the unit vector. Hopefully that makes sense. All right? Perfect. Why was my midterm asked? I want to know that question. The problem is that every one of the instructors, when I took this class, aren't teaching it anymore. Dr. Layla wasn't, well, she may have been, but Dr. Yuxing Chen wasn't there. Maha definitely wasn't there. This is her first year. Carlos wasn't there. Who's the other one? Dr. Manuli, she wasn't there. I'm not even sure if that's her name, Dr. Manuli. So yeah. Where did I get the 1 kilonewton? That came right from the question. It says that the Z component is W over 4. And we know that the W is 4 kilonewtons. So 4 kilonewtons divided by 4, it's equal to 1 kilonewton. Hopefully that helps. How can I explain? Well, it says right in the question. And basically where it comes from is if I were to look at point E, and this is going to scare you guys, don't run away, okay? Everything's fine. If we were to do force equilibrium, and we had our force going up, and we had 4 forces going downwards, and this was 4 kilonewtons upwards, well then all of the forces, if they're equal going downwards, they all have to be 1 kilonewton. That's where things start to get really messy. Really messy. Yeah, so great question. This question's often mistaken for like a force equilibrium question, but it's not. It's a moment question. It's mean. All right. So now we're going to start using the cross product. We have our force vector. Now what we're going to do is we are going to find the position vector that we need. Again, I have my force vector, and for my position vector, I want it to go from F down to E right here. So I want the position vector R FE. Just like that. Because that's what I'm trying to get. I'm trying to get that distance. How does it get the unstretched length? We're going to talk about that at the end. It'll be kind of the big secret. You guys ready? So we're going to come down here. Actually, we'll go up here. If we were to look at this really quick, it's going to be RE minus RF. So if we were to do this, the first two components are both 0. 0I plus 0J. And then we're taking E, which is 1, and we're subtracting F, which is alpha. So we got 1 minus alpha in the K direction. So I'm going to come down here and say, okay, R, I guess what were the subscripts again? FE. Well, this, of course, is going to be equal to 0I plus 0J plus 1 minus alpha K. Lots of fun. So now we're going to do the cross product. We're going to do it exactly how we would do before. We're going to take RFE, and we are going to cross it with FEA. So if I were to give you a tip for the midterm, again, I don't know the questions, but this is what I would say. If you ever have an unknown distance, right? Let's say you're given a moment and you want to solve for distance. Express that distance as an unknown variable. In this case, I have it as alpha. And then just go regularly throughout the cross product. That's what I'm doing. We have an unknown distance, that K component, but I'm treating the question like I knew the distance. I'm just keeping it as a parameter. So I'm going to go down here like this. We know that the first row is going to be that I, J, K. The second row is our positions. So 0, 0, 1 minus alpha. And then our last ones are forces. So 2, -2, -1. Now you can do, why is it 1 minus alpha? That's a great question. If we were to go to the top here, we know that point E is 0, 0, 1. I said that point F is 0, 0 alpha. If I were to find the position vectors, I don't know why I drew an arrow at the top. What I'm doing is I'm taking RE and subtracting RF. So the 1 comes from E, the alpha comes from F. Hopefully that makes sense. Referring to this spot right in there. Perfect. If you guys have questions, let me know. As long as the chat doesn't get sidetracked. I thought maybe maybe I should start a Discord server, and then you guys can ask me all your weird questions later on. That'd be mean. Your instructors were very kind to create Discord servers for you guys, and they were so great. Well, actually, most of them. Most of the servers are full of energy. Not all servers. For instance, some of the servers are rather dead. All right, so we're going to continue on. We're going to do the cross product. So I'm just going to do it really quick because it doesn't really matter which way you guys do it. So for the first one, you have 0 minus negative 2, 1 minus alpha, like this, and this will be in the I direction, and minus 0 minus 2, 1 minus alpha. This will be in the j direction. And then we have plus 0 minus 0 in the k direction. I'll upload like my actual, I'm using them as a cup holder right now, but I'll upload my actual notes later so you guys can see what exactly I did more clearly. So if I were to do this, and I were to substitute everything in, I'll just look at this. This is what we get. We get 2, 1 minus alpha in the I direction, plus 2, 1 minus alpha in the j direction, plus 0 in the k direction. So this is our moment. Now if we go up to the very top, it says that the magnitude of this moment, it's kind of highlighted, oops, right here. The magnitude of this moment is equal to 2 root 2. So what I'm going to do is I'm going to come down all the way to the bottom, and I'm going to take the magnitude of the moment. Again, this is our moment here. So if I were to take the magnitude of our moment, this is going to be equal to the square root bracket 2 bracket 1 minus alpha squared plus 2 bracket 1 minus alpha squared, and then it's plus 0 squared. I won't include that because it's no fun. And this is where all the fun begins. This is where all the fun begins. So the first thing I'm going to do, you can solve this however you want, because we know that this is equal to 2 root 2. We have essentially one equation with one unknown. We can solve for it. So what I did was this. I said, okay, I'm going to take these 2's and I'm going to multiply them in really quick. So basically what I have is the square root of 2 minus 2 alpha squared plus 2 minus 2 alpha squared. You guys are thinking, wow, Clayton, that's really inefficient. Well, I don't really care. I do it my way. You guys should do it however it is most comfortable for you guys. That's why I never tell you guys use the fish method. Is the fish method the best? Who knows? Who cares? Whatever's the best for you, always do that way. So if I were to simplify this, I have two terms that are exactly the same. So I have 2 bracket 2 minus 2 alpha squared. And we know if I wanted to, I can take that 2 root 2 and I can take that 2 and substitute it into the square root. Oops, come down here to get root 8. Again, I just took the 2 above and I threw it inside. How long is the review session? It'll probably be over soon. I'm going to finish this question. I'm going to call it a night. I will upload the third question that I did, and I'll upload all this stuff too. And yeah, we'll see how it goes. Maybe I'll do one tomorrow. We'll see. We'll see. Maybe. See how well my Animal Crossing island's doing. Stuff like this. So what's nice is if I were to look at these two, I'll switch colors again. I got something inside of a square root is equal to something inside of a square root. So we know that 2 bracket 2 minus 2 alpha squared is equal to 8. So hopefully that isn't too bad. And I say, okay, well, I can divide both sides by 2. So I got 2 minus 2 alpha squared is now equal to 4. Again, I just decided to divide both sides by 2. But here's where the trick comes in. Here's where the trick comes in. This question's full of tricks. I hated it. This is the last trick. I'm going to square both sides. Right? I'm going to square root both sides. On this side, I get 2 minus 2 alpha. I just took the square root of 2 minus 2 alpha squared. Question for chat. I just about said Twitch chat. You guys aren't Twitch chat. Question for Zoom chat. If I were to square both sides, so let me just go to a different color. Let's go purple. What I did was I just squared both sides. What's going to be on my right-hand side? You guys know the trick. See, you guys are super smart. But that got me in first year. I didn't get this question right. It's plus or minus 2. Plus or minus 2. I forgot about that. That got me good. This is more like Math 100 crap than Eng 130. So if this is the case, and we were to then solve for alpha, we get alpha is equal to two different things. We get alpha is equal to 0, and alpha is equal to 2. If we were to come up to the very top here, and we know, I'm just going to zoom in right here. We know that point E, oops, I don't know why it switches the pen. Point E was 0, 0, 1. And we said that point F was 0, 0, alpha. Does it make physical sense that alpha is 0? What do you guys think? Yes, no? No. So we know that alpha has to be 2 because we know that alpha is above 1 meter. Has to be above 1 meter. So that's the trick. We come down here. We can say alpha, to make physical sense, alpha is equal to 2. Now this is nice because I can go up here and I can say that I had a position vector, and I'll highlight it here. I had a position vector between those 2 points, and it was 0, 0, 1 minus alpha. We had an unknown alpha, so we didn't know what exactly that position vector was, but now we do. We know that it is 0, 0, 1 minus alpha. So if I were to come down here, we know that position vector between those 2 points, and I'm not going to bother with the subscripts. Oops. I will bother with the IJK though. 0 plus 0 minus 1k. Why is this important? Why is this important to us now that we know that full position vector? Well, actually, let me ask you a different question. What does the magnitude of a position vector represent? Distance. Distance. So basically, if I have those 2 points right here, and I had a position vector r between the 2 points, so we're just going to call this r, well, the distance between these 2 points right here is going to be the magnitude of the position vector. What is the magnitude of this position vector? 0, 0, negative 1. 1, exactly. So now we know that this is 1. What does this mean? Well, if I were to look up at this diagram, that distance FE, that is the stretched length of my spring. That is the stretched length of my spring. So if I were to come down here, we know that this length that we just solved for is the current length of my spring. If we go back to our spring formula, the force in the spring is equal to K of L minus L naught. And again, the whole question was determining L naught. Do we now know everything except for L naught? What do you guys think? Do we now know everything in this formula? Yes, exactly. And I'm going to ask you guys now. You guys are on your game. Let's see. K, I'm not going to bother with because if we go up to the top of the question, it gives us K as 10. It gives us directly that K is 10. So that's no problem. So we have 10. We got our current length, which we said is 1 minus L naught. So that's all good to go. The last thing we need is the force in the spring. So let's go up to the very top. What is my force in the spring? 4 kilonewtons. You guys got it. That spring is supporting the whole plate. And the weight of that plate is 4 kilonewtons. So all that force is in the spring. So we come down again. We have basically 4 kilonewtons. And what we find is that L naught, the unstretched length, is going to be 1 minus 4 over 10, which is equal to 0.6 meters. How about that for a question? Lots of fun. Lots and lots and lots of fun. Not fun at all. Not too shabby. Yeah. GG, exactly. When I took this, it was before press F in the chat. I didn't get to have that luxury. When I took this exam, it was a whole different world out there. Things have changed. Hard question. This is the hardest question I think I've ever seen in my life. I have all the midterms. I have all the secrets. I got things that you guys wouldn't expect me to have. Hardest one I can find. Hardest one I can find. Worse than friction? We're just talking about midterms here. Friction's different. All right, so that's going to cover the review. I will upload all of these examples tonight, okay? I will upload all of the examples, so if you want to see the written work, you guys can see the written work.